Good morning, folks. So you've got that challenge question in front of you. It is 10:13. We'll talk a little bit more about this question at 10:15, and then we'll get class started for today. All right, so we got a little bit of time yet.
This free fall assignment thing killed me inside. I cannot remember for the life of me how to isolate T.
Okay. I think that last class we talked about how like today we can talk about that assignment a bit. So if you've got some questions about it, awesome. We can kind of go through a couple things today, including like isolating the T there. It's a bit of a I was going to say tricky. I don't know if tricky is the right word, but like it's expanding on what we have been doing. It is like a little bit more difficult.
So, I mean, I think I remember that we talked about it a little bit, and so I just kind of used my notes. I don't know if my notes are right or whatever, but that's just how I did the assignment, and I think turning out okay, but I'm not sure like at all. So
Okay. Well, Krista, that sounds great. It sounds like you were spending some good time working on it, and then maybe today, as we talk about it, you'll go like, oh yeah, I feel like 100%, I did it correctly. Or maybe you'll say like, oh, there's maybe one thing I want to change or something like that.
Okay.
Yeah. Cool. Good. Good morning, by the way, Krista. And good morning, Jada. Okay. All right, well, folks, it is 10:16. You do have like 4 more minutes for this question. It's not, honestly, it's not really a question that requires a huge amount of time, but let's kind of remember that, hey, if we're simplifying, that usually means that we try to express it as a mixed radical in simplest form. And so a mixed radical, of course, will have some number out front. Maybe it's a 3, and then some number inside as well. Right? Maybe it's a 2. Okay. For this question in particular, what we want to do is our factor tree, or you can use one of the other methods that we've done in the textbook. You have factor tree where, for example, this is 2 and 90, which is 2 and 45, etc. Right? And then we want to find the things. We want to find the ones that have a pair. Right? This is a square root. There's an invisible 2 right there. Invisible. And so we're looking for taking out pairs of numbers. So for example, let's say we had a different question. Let's say we had the square root of, let's say the square root of 32. No, 48. Let's say the square root of 48. Okay. If we're doing this question, we can start doing our factor tree, 2 and 12, 2 and 6, and 2 and 3. We can bring out, we can circle the pairs, and I put a little square around it. This is our prison analogy, right? So we're helping one of the numbers escape. And so after doing that, the 2 and the 2 are the ones that are able to get out, right? So 2 times 2 is 4, we put that there. And then the thing that is left over is this 3. The 3 didn't get out, didn't have a partner to help them escape. And so that would be our final answer. This is what we call simplified, because this number here, this number, well, what we can say is that it's simplified because there's nothing else we could take out of the radical. Okay? The radical is as small as possible. Any questions about that? Okay. Yeah, fairly straightforward, I think. All right. Well, maybe right now is a good time to talk about that, that assignment, that free fall assignment. And so I'm just kind of getting some stuff organized here, opening up the chat. And I want to hear from you folks. What are some things that you'd like to talk about with respect to that assignment?
How to isolate T.
Okay, how to isolate T. All right. Anything else?
If it's supposed to be decimals, like if what we're putting into the table is supposed to be decimals.
Certainly, yeah, you certainly could be getting decimal values for some of these distances and some of these times. Yeah, certainly. Okay, task 1 we kind of did a little bit in class, and I think the isolating, that's going to be part of task 3. Okay, so we can talk about that. I'm going to do a little bit of that work just here in this empty space. Let me just scroll down and let me zoom in a little. How's that? That's not bad. Okay, just perfect. All right. So task 3, isolate the variable that is this here. Rearrange a formula to isolate T. So the original formula is this: D equals 1/2 a T squared. Okay. And if we're isolating T, I'm going to color it differently. If we're isolating T, that means we want to try to get everything else that's on the same side as T, we want to get it to the other side, right? So that means this 1/2 we want to get to the other side. This A we want to get to the other side. And even this squared, we want to do something with that. We want to get that to the other side. And there's a lot of different ways that we can think about doing this kind of work, right? This is algebra, we're rearranging equations. Some people prefer to think about how, hey, if we have an A here that's multiplied, we have to do the reverse process to the other side. All right. And that's good. That's a good way of thinking about it. What I prefer to do is I think, hey, if we want to bring that A to the other side, yeah, it's multiplied here. If I divide the whole thing by A, I cancel it out, right? That A and that A get canceled out. But of course, if I do that to the right side, if I divide by A on the right side, I've got to divide by A on the left. Okay, whatever we do to the right side, we have to do to the left side. And so writing down our next step, we have D over A equals 1/2 T squared. Next, I want to tackle this 1/2. And this is where we talked about, hey, we can do the same thing, right? Because we've got 1/2 times T squared. We could divide by 1/2. It looks messy, and it would look really messy on the other side as well. And so I want to invite you to think about how, if we have something in fractions here, if we have like a number, if we have a fraction here, we can multiply by the opposite fraction. For example, we can multiply by 2 over 1. Really, that's just 2, but let's just see what happens here. If we multiply by 2 over 1, well, this 2 here gets canceled with that 2, and this 1 gets canceled with that 1. So we've canceled everything out. But of course, if I do that to the right side, I have to do that to the left side as well. And so that leaves us with 2d over a equals t squared. And I'm just going to write it one more time here. 2d over a equals t squared. There's a couple of different ways that you could write that, right? So it could also be written kind of looking like this. 2 times d over a. You could even leave that multiplication symbol in there. All of that is okay, right? However, don't write it like this. This is not correct. Okay, that's different, right? That 2 is not in the denominator. All right. Finally, the last thing is to do something with that squared and to cancel out any square root, right? Like, let's say we had 3 squared. Well, if I wanted to just get 3 by itself, I realize I can take the square root of this side, and the square root and that squared cancel each other out, leaving me with just 3. So that's what we can do here. We can do the square root of this side and the square root of this side. The square roots on the right cancel out, leaving me with t. And then over here we have this square root, and then everything here, 2d over a. And of course, you might choose to just put the t on the left side. That kind of looks nicer, but you don't have to. All right. Any questions about that?
So after you've gotten to the 2dA, you'd have to first times, say that d was the 10. You times d by 10, or 2 times 10 to get 20.
Yeah.
Then you divide by 9.8.
Mm-hmm.
And then you'd square root it?
Yeah, should we try one of them? Okay, let's try one of them. I'm gonna erase. Oh, it'd kind of be nice if there was a faster way to erase a big chunk of things. Okay. So we will write this here. T equals square root of 2d over a. That's a d and that's an a. Okay, so let's say we're trying this one here, a distance of 10. Well, we want to find out what the time is. We're going to plug in our value of 10. My 2's are really messy, aren't they? 2 times 10 divided by, and then we know what a is as well. It's 9.8. And then, so this is 20 divided by 9.8. I don't know what that is, right? Can anyone calculate that? Does anyone have a calculator handy?
It is 2.0408.
2.0408. Okay. Now, right now, this is too many decimal places, but it is kind of nice to just keep those decimals around until your very final answer, right? So then we can find the square root of that, which is going to be about 1.4, isn't it? T equals about 1.4. And I think that's good enough for me. I think just one decimal is fine. So that's 1.4 seconds. Yeah, what do you think? Yeah, good. Good question. So, you know, if you've handed this one in already, that's great. If you haven't, you know, you've got until like at least the end of the week, right? If you want to take until the end of the week to finish this up, that's fine. All right. Any other questions about this assignment?
Oops. What do you mean by compare and contrast the two graphs?
I guess I could provide a little bit more detail there. What I'd like you to do is maybe think about describing one way that they're similar and one way that they're different. Okay, the shapes of the graph. So for example, that first graph, if I can kind of like do it off the top of my head, I think that first graph is going to have some sort of curved shape, right? And the second graph will have some sort of curved shape as well, but it'll be curved in a different way, right? And so can you describe like how the curve is the same and how the curve is different? How is the shape the same and different? How is the shape different? All right. Hey, I haven't said good morning to everyone. We have Drayden. Good morning, Drayden. Good morning. Good morning. And we have Noah. Good morning, Noah. And we have Steve. Steve. Okay. All right. All right. Folks, any other questions about that one there? That assignment? Morning. Thanks, Noah.
So then just quickly, so do we just like write it down in like a couple of sentences then?
Yeah, just 2 sentences is enough for sure.
Okay.
Yeah, I should have been more like descriptive there, just to say like, 2 sentences max. All right. Good. So folks, you may recall that I said that we would have a test, a chapter 1 test available. What day did I say it would be available?
Wednesday, I think, today.
Yeah, and today's Wednesday. So it's ready. I just realized I forgot to include one thing. I'm going to include on the test page what do you call them? The like exponent rules. Okay, so you can see the exponent rules on the test page if you find them useful, right? And so I encouraged folks to have a look at the chapter review section in the textbook, and you can review some of the questions that were assigned for homework, that kind of thing. All right. I think the difficulty is it's right around a medium difficulty test. That's how I would describe it. Yeah, I haven't tried to make it like a very difficult test. Maybe chapter 2, I'll try to make a little more difficult, but we'll see. We'll kind of assess that as we go. I think it's 15 or 16 questions. One of them requires you to just type a simple explanation. The other ones will all be multiple choice or numerical response, where you type in a number, right? Yeah. So that will be available probably 20 minutes after class is done. So you could write it today, but it will be available up until the end of next week. It's a long time, right? By the way, did you know that next week, we go up until the end of next week, and then we have a 1-week break off of classes? Did you know that? If my calendar is correct, and I think it is, we have Thanksgiving on that Monday, and so we've got kind of that whole week off of classes. All right. Yeah, that's kind of exciting. My wife and I are hoping to, we're going to Ontario to visit some friends of ours. So that'll be really nice. We're having Friendsgiving. All right. So Thanksgiving is one of my favorite holidays, I gotta say. That's a nice holiday. All right. we're moving on to chapter 2. Chapter 2 is all about polynomials. And so in this first section, 2.1, we're talking about these key ideas. Well, first, what is a polynomial? We're defining a few things: term, polynomial, degree, leading term, that kind of stuff. I think there was one or two more key words that we're going to learn. We're going to learn this process of simplifying polynomials. Okay, I think this is stuff that we've done a little bit with this in the past, and we're going to do more with it coming up soon. So we're going to open up our textbook to page 63. Okay, page 63. And it's loading. Here we go. Okay. How are you folks doing today? I didn't ask. Is everyone doing well? Yeah, not bad. Okay, seeing some nods. Okay, good. All right. So there's going to be a few basic definitions that we're going to make here. All right. So we've got this definition: a term. A term is a number or product of a number with one or more variables which can be raised to a power. And what I've said before too is that terms are things that are separated by pluses or minus. So when we've got something like this is an expression with two terms. Here's one term and here's another. It's separated by a plus sign. And this definition here is telling us it's a number, right? So I could add one more term here that's just a number, 2. It's a number or a product of a number with one or more variables. That's what these ones are, right? 2xy is a product of a number with variables. So it's 2 times a variable x times another variable y. So this is a term. This is another term. Because it says it can be a variable which can be raised to a power. So 7 is the number, and then x is a variable raised to a power. So each of these things are terms. All right. Okay. We have some examples here. So we're saying that 5y is a term. The coefficient of it is this 5, right? So the number in front of the variable is called the coefficient. In this case, it's 5. And the variable is y. Okay. This is a term. This one here is a term. The coefficient is 1/2. That's the number out front. And then the variables are x, y, and z. And then, of course, this is a term. This 10 is a term. The coefficient is 10, and there is no variable. We sometimes call this a constant. Because it does not vary. It does not vary. It has no variable. We'll look as well at this one here. This is x. The coefficient is that invisible 1. We go 1 times x, and the variable is x. Let me know if you folks have any questions as we go. Next up, a polynomial. Polynomial, this is kind of the whole chapter is about polynomials. A polynomial is a term or sum of terms in which all variables have whole number exponents and in which variables only appear in the numerator. So we got some rules. We got some rules that tell us what a polynomial is. First of all, that term polynomial, poly means many. Did we talk about this in class already? Maybe not. Poly means many. Nomial means it means names, right? So many names or many terms. Okay, many terms. All right. So, for example, these are all polynomials here. Okay, 5. Yes, it's a very simple polynomial. No variables. It's just one term. That's a term. Okay. Here, this is a polynomial. Okay. But I want you to compare it with this one over here that is not a polynomial. Why do you think this red one is a polynomial, but this blue one is not a polynomial? Can anyone provide me with an answer?
Because it's adding a square root.
Well, this one has a square root too. I'm sorry, Krista, you're correct, but I'm kind of being like a stubborn student here. Well, this one's got a square root too.
Because you're adding a variable to a square root.
Okay, yeah, so we're taking the square root of a variable, and that is what makes it not a polynomial. Exactly. Okay. So we say here all variables have whole number exponents. Well, if I've got the square root of y, that's like writing y to the power of what? Y to the power of? Y to the power of?
2.
Y to the power of 1 over 2.
Yeah, 1 over, yeah.
Yeah, y to the power of 1 over 2, thank you. So we can see that this is not a whole number, and so it's not a polynomial. All right. And similarly, look at this one. We have 1 over 2x. Of course, we've got the variable appearing only in, that's in the denominator, but we've said a polynomial can only be in the numerator. This one too, look at this. This is not a polynomial, x to the power of -3. And another way to think about that, of course, we can write it as 1 over x to the power of 3. You can see we have a variable that's in the denominator. It's not a polynomial. Okay, we're doing okay. Any questions so far? Okay, good, great. We have different ways of classifying polynomials. So we use these prefixes, mono meaning 1, bi meaning 2, and tri meaning 3. Okay, a monomial has one term. Like we're like just ignore these for now, right? This first one, it's just a 3, so that's a monomial. The second one here is just a 2x squared y. That's a monomial. And this last one is a -3a. It's a monomial, just one term. Binomial, of course, has 2 terms. Look at this first one, x plus 2. X is a term, 2 is a term. So there's 2 terms there. Here's another binomial, right? And then finally, here's another binomial. I find these lists kind of confusing. With the commas here, it's hard to distinguish between the different polynomials. Trinomial, of course, you got it, has 3 terms. There's one, and here's the other one. And then a polynomial is, we just use that to describe any of these things, but it can be, of course, more than 3. So this one has 4 terms. And this one has 4 terms. All right. Yeah, let's look at this one here. Let's look at a couple of these here. There's this concept of the degree of a polynomial, degree, right? Degree of a polynomial. This one here has degree 5, okay? This one here is degree 2. This one here is degree 1. This, and maybe we'll kind of just stick with those 2. Can you guys solve the puzzle? What am I talking about? What makes that one degree 2? What makes this one degree 5? And so on. Can you guys see what it is?
It's the exponent. It's the highest exponent.
Highest exponent.
Yes. Yeah, we got the brothers chiming in there. Thank you, brothers. It's the highest exponent, right? So for example, this one here, each of these has been put in a very nice order. This is how we like to write our polynomials, starting with the highest exponent and working our way down. So this one here, the highest exponent is first, and it is a 5. Okay, so this is degree 5. Degree 5. Great, exactly, right? And so that's what we're talking about on the next page here. Degree of a polynomial. The degree of a term is the sum of the exponents of the variables in that term. So I did make a mistake on one of the previous ones, my mistake. The degree of the polynomial is a term with the highest degree, right? So we can tell by looking at this one, the degree of that one is the leading term here has x squared, okay? So the degree is 2. Have a look at this one. We've got our highest term here. That's 4x squared y cubed. Highest degree is from this one. And what we do is we take the 2 from the x and the 3 from the y. We add them up to get 5. I forgot about that, so that's important. And this one here, we're going to add them all up. Look what we get. We have a 2 here, 2 on the z. What about the y? What is our exponent on the y?
One.
Yeah, there's that invisible 1. So we're going 2 plus 1 plus 2 equals 5. That's degree 5. So if you've got more than one variable, you've got to add up the exponents from each one. Questions? Questions? No? Yes? Oui? Non? Bonjour. Je m'appelle polynomial. All right, next, leading terms. My name is not polynomial, but that would be a fine name, wouldn't it? Leading terms are the term with the highest degree. So we call it leading because we usually put it first. If we want to, like, if we ordered things the way that we prefer to order them, the leading term would be first. For example, consider this expression, this polynomial. Okay? We have 3 terms, 1, 2, and 3. The leading term, of course, is this one here. We've put it in the front. It might not always be in the front. Maybe we got to do some work to rearrange and put the leading term there. But it's a highest degree one, so that's our leading term. Furthermore, we can tell that the degree of this is 5 because we go 2 plus 3. All righty. Questions? We're doing a lot of little things, and some of this is review here, but of course we've got combining like terms. I think we've done this a lot, right? Where, hey, these are like terms, so they could be combined. These here are not like terms, right? XY squared is not the same as x squared y, so they cannot be combined, all right? Here we've got an expression that we're asked to simplify. That means we're going to try to combine all the like terms that we can. What I've seen done, I'll show you a couple of things that I've seen done to kind of help with this. One thing is that we don't bother combining right away. We just put things in order so that the different terms are next to each other, right? So I moved that minus x squared closer to the 4. And the minus goes along with it. And then in my next step, I do the math. So I'm going 4x squared minus x squared. That's like 4 minus an invisible 1. That becomes 3x squared. And then we have negative 3y plus 5y. That becomes positive 2y. Okay. So that is one way that we can do that kind of work, just by rearranging things. Another way that I've seen folks do it is that we use different shapes for the different types of terms, right? So our x squared, I'll do a circle. There's one, and there's one. And for the y's, I'll do a triangle. So there's one, and there's one. And it just helps visually keep those straight. So we can kind of go through then. 4x squared minus x squared is 3x squared. And we have negative 3y plus 5y is plus 2y, right? Questions regarding that? Maybe I should, no, I shouldn't stop asking if you have questions. I'm going to keep asking, but also feel free to kind of interrupt with a hand up or anything like that. Okay, we've got evaluating. Again, this is something that I think we've done before, right? So if we, for example, have a polynomial 2x cubed plus 5x, and we are asked to evaluate for x equals 3, what we're going to do is we're going to replace x with our 3, right? So we've got this 3 that we're plugging in there, plus 5 times 3. Okay. And that means that this first thing here, I'll do the exponents. We've got 3 to the power of 3 is 27, plus 5 times 3 is 15. And so that becomes 54 plus 15 is 69, okay, is our final answer. So there you go. Now, these multiplying, this we're going to get more into in our upcoming sections. Multiplying, again, if we're multiplying monomials by a monomial, it's fairly straightforward, right? This first one here, what we're going to do, we can multiply our numbers together. So we got 2 times negative 3 is negative 6. And then we look at each variable. So we're going x cubed times x to the power of 4. We know that's going to be x to the power of 7. When we're multiplying those variables, we can add the exponents. It's kind of what we're showcasing here. We've got the 2 times negative 3. We put that there, and we've got the x cubed times x to the power of 4. Right? Got it broken down a little bit more. This last one here, right, we've got negative 3 times 2 times 4. That's going to be negative 6 times 4, negative 24. We've got y squared times y to the power of 3. So we've got 2 plus 1 plus 3 is y to the power of 6. And z, we've got 3, 2, and 2. So it's 3 plus 2 plus 2 is 7. So we've got z to the power of 7. Right? And down here, we've got something similar, but we're kind of breaking it up into each piece. All right. Now, next up, a polynomial by a binomial. This is more complex. This is stuff that we have done before, I believe, but we use something called the distributive property. So if we have something that resembles this, and all we're representing is that we've got 3 terms, one of them is outside the brackets and 2 of them are inside the brackets. We think about how the distributive property is, we take that A and we distribute it to every bit inside the brackets, right? So for example, if we have 20 times x plus y, right? I think about this like so. If I'm going to give everyone in the class $20, right? If I'm going to give everyone in the class $20, I'm not going to give that whole stack of cash to Drayden, right? No, I'm going to distribute. I'm going to give that $20 to each person, right? So the distributive property. I'm giving this $20 to this person X. So it becomes 20x. I have a plus here, and then 20 times y is going to become 20y. Okay? All right, great. Let's look at this one example here quick, right? We got this, okay? Actually, I'm gonna clear that out. Let's do it like this. So we've got negative 3y times x to the power of 4. That becomes negative 3x to the power of 4y. I like to put those x's first. It's our first term. And then we're going negative 3y times 2y cubed. It's going to be minus, it's going to become a minus 6y to the power of 4. All right. Questions about that?
The reason it becomes a negative is because you're timesing a negative by a positive, right?
Yeah, that's right. That's right. So we can think about that negative 3 times positive 2. And so if you wanted to, you could write it a slightly different way. You could write this plus negative 6y to the power of 4. But of course, that can be simplified too. The best way to write it is just like this. Yeah. All right. Questions? What percent, can you type in chat, okay? Somewhere between 0 and 100%, okay? What percent of this lesson was review? Meaning you've done it before in previous math classes. What percent of this felt like review to you? Was it 100%? Was it 60%? 50%? Okay, about 20%. What percent of it was review? If you don't mind typing in chat. Okay, I see someone saying 1%. Okay, 1%, 100%. We've got a big range. 75 to 80, 90%. Okay, all right. 80. Okay, so maybe yeah. That's I kind of expected that some of it would be review and some of it would be new. So if it was totally review, at least I hope that it was kind of helpful to review this stuff. Yeah, okay, all right, good, thank you. Folks, why don't we take a 7-minute break. Set a timer, okay, Google, set a timer for 7 minutes. And then we'll come back after that to continue class, okay? There it goes. All right, see you in 7 minutes.
Friends is not that good.
It's better than Brooklyn Nine-Nine.
Oh, it's not true.
It's true. It's the best. I think it's like the most watched TV show.
That doesn't make it better.
It does make it better.
No, it's just not as good.
It's so much better.
What about The Office?
Office is like dumb. I don't like The Office.
You know what? You're like
I 100% agree.
Well, what?
Meh.
But Brooklyn Nine-Nine.
Oh, that show sucks.
Oh,
Yeah,
I love that show.
I know.
Okay, you know what?
Friends is actually garbage.
Uncultured swines.
No, Friends is so much better.
To be honest, I don't even really like Friends that much.
Friends is not good. I tried watching it. I couldn't. It was too bad.
Have you guys seen The Walking Dead?
No?
It's so scary.
Yeah, there's no way in a million years my parents would let me watch that.
Exactly. Like, no way my parents would watch that. And if I did watch it, I'd probably end up laughing comparatively to being scared.
I cry.
Whoa.
It's so scary. You watch it. I always watch TV shows at night before I go to bed. And like, I'm like watching it and like in the dark, I'm like, looking to like my bathroom door. I'm like,
The Bluetooth headphones don't want them to die, so I have to turn them off.
this weekend I'm gonna go watch The Nun.
Oh
I
yeah.
want to see that.
That is,
I went to watch Venom.
Oh, I want to see Venom so much.
So much.
So much. I'm well at grammars.
I'm well at grammar, so. No, one of my friends, he's like, Hunter, we gotta go watch The Nun with Maya and Darian. And I was like, let me watch the preview first, because I was like, I'm gonna freak out. Because one time I watched it, because my friends made me go see it with them, and I held her hand the whole time, closing my eyes. So I was like, okay, like I gotta watch the preview before like I'm gonna go to the movie, because I was like, I'm gonna get scared. He's like,
Yeah, I'm the kind of person who will go into a kitty haunted house and I'll just close my eyes.
My sister laughed while watching it. She laughed the entire movie.
watching what?
It.
Uh,
Have you guys seen 2012?
yes.
Okay, I laughed so hard during that movie. It was hilarious.
I like the guy who just like is like in his like a minivan or whatever, and he just like stands there. I'm like, I feel like that would be me, honestly.
When you realize they're not going to space.
They didn't go to space.
No. It was flooding in 2012, and they made like a Noah's Ark thing.
Oh. Yeah. I recently just watched that again.
And you didn't remember that?
No, I don't think I watched the end of it. I always do that. I always watch half a movie and I'm like, no, I'm bored.
Yeah, I did that with Guardians of the Galaxy. Everyone's like, oh my gosh, it's like the best movie ever. And I was like, halfway through, I'm like, this is the most boring Marvel movie in the history of the world.
I
Like Chris Pratt is like my favorite actor of all time. So
Watch James crying.
because he just got dunked down.
I ain't even lying.
No, he just got dunked down.
Standing in the way.
So I jumped up in the air and I dunked it on his face. Dunked down.
anyone else realize I eat the whole class?
He was getting pretty mad.
Yep.
These aren't even my rice crackers.
Ruben. What?
You want?
I constantly eat. Like, I don't think I ever stop eating.
Yeah, same.
I
I
have
don't know what it's like to not be hungry.
I have two activities in my life. Eating and sleeping, and that's about it.
Hunter, where do you live?
I live in Crofton. That's near Duncan.
You live in Crofton too?
Me?
Yeah.
You didn't know that?
I was so confused because we live in Crofton too.
You live in Crofton?
Yeah, we live right behind the grocery store.
Ruben. Ooh.
Like the top grocery store, right?
Yeah, Crofton Foods.
Oh yeah. I thought you lived in Duncan. I swear you
Nope.
lived in Tamara.
We did, and then we've moved 3 times since then.
Answer me, Ruben. Ooh.
Hunter.
Hunter lives in Crofton?
Hunter lives in Crofton.
Where?
I don't know where she lives.
Not like
Keep on
in
flying.
town.
You like in out near Totlow?
No. Like,
Oh.
you know where the mill is?
Oh yeah.
We're like a little bit down. You know that farm?
Oh yeah, I know where your house is. It's
That's
like
our
yellow.
farm.
Yeah.
No, that's my grandparents.
That's your grandparents? Oh, I just know because I was driving past and Ben Williams was like, that's where the Cooks live. And I was like, why do you know that? And he was
I
like,
didn't know that.
I don't I don't know.
That is weird.
Yeah. You guys are all like, oh my gosh, you guys live so much closer. I'm just like, yeah, I'd have to take like a 2-hour ferry or something. So I'm good.
Krista, are you on the mainland?
Yeah. I live in Abbotsford.
Oh, okay.
Ha.
And you guys were all talking about living in Crofton. Hey, sorry, I didn't mean to, like, I overheard that conversation. I grew up in Crofton. And my parents still live there, like kind of down, do you know Vi Road? Yeah, down that way. down that away. All right.
I just moved here.
Oh, okay. Where'd you move from?
We moved from Mill Bay.
Okay. Yeah.
Yeah.
Cool.
I know.
I really like Crofton. I think Crofton is a terrific town. Got everything you want. It's got the mountain. It's got the ocean. Yeah. It's got a grocery store.
Yeah. Two grocery stores that are
Wow.
overpriced.
What more could you need?
And you know what? It's so funny because I live just up the street from like the biggest mall. It has like seven big stores and a bunch of little ones.
Listen here, the mall is probably same size as Crofton.
Yeah, that's probably true.
You had enough of it. You had it. Just have some meatball then. You have it. I'm great.
All right, folks, it's time to keep going here. Ruben, can you get your brother, please?
Yeah, he's going. He's just coming back.
Okay, good. All right, folks. So for the next bit here, what I want to do is I want to split you guys into two groups, and I kind of want this to be a little competitive. So I'm trying to think of how we want to do this. I'm going to split it up into two groups, and what you'll see on your what I'll link to is a document that has one big like expression where it's multiplying many like polynomials: x cubed, y squared, x squared, y squared, etc. Right? And your task as a team is to multiply, simplify. Right? We can say we want you to multiply everything. Okay. I want to see if I can get you guys to race to see which team can figure it out first. Okay. Whoever gets it first is a winner. However, if you submit it first, but you're not correct, even if you're just off by one exponent value, then you don't win. All right. Okay. So we're going to try to race to do this. Okay. Are there any questions before we just get to the next page here?
So like just those three?
No, this isn't it. It's even bigger than this.
Oh,
all right?
Okay. Oh, I see.
For
example. There's more. I see.
Yeah. There's going to be, it's not in your textbook.
Yeah. Okay.
Will we be able to use calculators?
Okay. So I did say no calculators. Calculators are forbidden, and any other math tools. For example, like Desmos, Wolfram Alpha, Photomath would really help, but that's forbidden, okay? You can use paper and pencil. Yes, you can use those things.
You said no other math tool?
Well, okay. Well, what do you mean, Jonah? Can you think of something
Well,
else?
your brain.
Okay.
Your brain is a math tool.
No,
so.
please do use your brain. Okay, the math tools.
I don't know.
Does Google count as a math tool?
Yes, you can't use that. The tools you can use: your brain, your voice to discuss, your pen, pencil, your paper, and maybe that's it. All right. Okay. So what I'm going to do, I'll show you it first, and then I have a document that I'll link to in chat, just so that everyone can click on it and they have it in front of them. Because once you get separated into your groups, it won't be up on the screen anymore. You know what I mean? Okay. And then I'll split you off into groups randomly. It'll be random. All right. Let's clear this out. With the group, expand the following huge expression. Calculators and external tools are forbidden. Additionally, list at least 2 pieces of advice for working as a group to quickly and correctly solve a problem like this. Okay, this is it. It's pretty big. All right, I'm gonna open this up so that it's in a document as well, right? And then I'm gonna link this to you folks so that you can have it in front of you. Okay, done. You can't edit it, but you can click on it to open it. So please do click on it to open it. because when I put you in a group, it's going to disappear from the screen. Hunter looks like she's panicking a little bit. Try your best, okay? Does everyone have it open? All right. Oh, people still clicking. Okay, meanwhile, I will start looking at our breakout groups. I think I have to, oh no, I can do it here. Breakout rooms, we're gonna have 2 rooms, okay? That's only 3 participants, 3 to 4 participants per room. All right, so the groups, I did move one person. The groups are gonna be Jonah, Krista, and Noah, Drayden, Hunter, Jada, and Ruben.
Can I ask something?
Yeah?
Was the person you moved Ruben?
Yes. How did you know?
Yeah, because he was in my group again.
Yeah.
I don't know why we're always in a group. It's weird.
Yeah, so I separated you two. I separated the brothers. Okay, folks, you ready? Here you go. All right, folks, welcome back.
I love hearing Mr. Bohr swallow the water. It's
Oh no.
great.
Oh my gosh.
That was a bad note to come into.
You know what? I should mute it.
I love hearing Bohr swallow the water. It's like, oh, okay.
All right.
That's my better.
Do you have everyone back here? Is everyone back?
Yeah.
I think so.
Hopefully.
So,
Hey,
Wait, we're missing Jada. She's
no, Jade is here.
okay.
Jada. Okay, great. Yeah, I think I see everyone. So, folks,
Not there.
we did have an answer first from group 2. All right, so group 2 has their answer first. What I want to do, the answer will appear. Hold on, let me just, oh, hold on. Did you guys see what it was?
Yeah.
No one saw.
No.
Okay, so the answer will appear. What I want is for, can you guys annotate? I would like someone to annotate, and maybe group 1, you could share your answer here.
Who's group 1?
Group 2 over here. Group 2, yeah, which one was right? Doesn't matter.
Group 2 is us.
Group
Yeah,
2.
group 2.
Okay.
Group 2.
Group 2 is you guys, so you can write your answer down there. Group 1 on the left side.
Okay, I can write the answer down, group 1.
Okay,
I got the answer on this side.
Thank you, folks.
Oh wait, no, we don't actually have an answer, but
And I hope I did it correctly. I think I did. I mean, I used external tools to help with this one. So.
Oh, I see how it is.
uh-huh.
Uh-huh.
Okay.
Huh. Oh yeah, okay. All right. Yep.
Okay. So
Group 2 got something typed out right there. Okay, I understand it. I understand. And group 2, that's the same answer that you provided me with earlier.
Yeah.
and so because we didn't actually have an answer, like we had just figured out our fraction
Yeah,
right as you close the break room.
I see. I see. So can you tell me like part of what you got?
So we got 4,846 x to the power of 7 and y to the power of 10. And then we were going to distribute it to the binomial.
Okay. All right. Good. So, and then, so there's a little bit of work left to do there. All right. So, are you folks ready to see the answer?
How
Sure.
wrong were we? Let's go.
Actually, before we do that, I want to ask you what kind of strategies, like what did you find was an effective strategy for working with that?
Splitting the work up
Okay.
was like a semi-effective strategy.
Semi-effective. How did you split it up? Because I think there's a few different ways you could.
Yeah, so we just did kind of what you suggested was one person did all the variables, like all the y, one person did all the x, and then technically two people did the numbers, the whole numbers.
Got it.
What exactly did Noah do?
Not really much because he got
Noah.
because it was my fault, but
Okay, well, no worries. And then I think I said to both groups, you gotta wait until the end to deal with that binomial, basically. All right, how about from the other group? What was an effective part of your strategy?
What we kind of did was we all worked together all the way through, and then Hunter double checked the work for it.
All right. Well, folks, I like what I'm seeing. You guys both got a lot of work done. Are you ready? Here is the answer. I got to click on the mouse, okay? This is my finger. It's going to click on the mouse.
Whoa.
Oops. There it is. All right. So, folks, as you can see, and in fact, maybe you would put those two backwards. So you both got a lot of work done with the variables there. Group 2 got very, very close, right? Very, very close. You got one of the terms correct. Yeah, you got one of those terms correct except for the minus sign. And then we just forgot to put the variables on the other term, that 972, okay? So it's very, very close. Nice work, nice work. This is meant to be really challenging. You'll receive a homework assignment where you're doing multiplication, but nothing with this many factors, all right?
Okay.
Yeah,
That's good.
don't worry about that. So here, I'll put that homework assignment. Thank you for participating in this. I hope it was kind of fun and not too much pressure. The winner is, I don't know, does group 2 win because they provided an answer first?
For the record though.
Yeah.
I think we should win.
Krista was freaking out at the end, so you said it wasn't too stressful.
Yeah.
I think Krista was a little stressed.
Okay.
Actually, when we finished, the first thing Hunter said was, that was really stressful. That was too stressful.
I see. Well, you know what? Then what I will say is if you experienced a bit of stress in this situation, I think that is an appropriate place to feel a bit of stress. So that's okay. Okay, it's okay to feel that stress, that competitive stress. All right, here we go. I got lost, says Noah. Yeah, it was a challenge, right? This is your homework assignment. Note that we've got one thing here that says try 10A, and so it means it's not really part of your assignment, but I want you to look at it, okay? We might discuss 10A next class. So this isn't too, I think this will go pretty quick, I think. To fill in the blanks, okay, so that's kind of definition. Number of terms. Oh no, that one I didn't assign. No. Yes or no. Monomial, binomial, trinomial. Simplify. Yeah. All right. Some good practice there.
And then just quickly, Mr. Bohr.
Yeah.
The number 1 means just do all of 1, right?
Yeah, that's right. And then for 3, 4, 5, 6, 7, 8, do A, C, E, etc. Just 9A and then try 10A. And folks, I would say within 20 minutes, your Chapter 1 test will be available. And it will be available until the end of next week. All right?
Do we print out the test, or is it an online format?
The test is all online. And so you'll click on it and it will list a bunch of questions, and each of those questions has either multiple choice or type in an answer.
Awesome.
You have a 90-minute time limit for it.
And we're allowed to use calculators, correct?
Yeah, you can use a calculator. You can't use Desmos or any other websites or apps or your phone or anything like that. Okay. All right. Well, Well, folks, enjoy the rest of your day. If you do have any questions here at the end, I'll stick around for a bit, but otherwise you are dismissed and we'll see you next week. Okay. Have a good day. Have a good weekend. Bye.